That's right. Get ready for something that's going to revolutionize the 3D printing space. This is the Enraged Rabbit clothing freshener. It has multi-material capabilities built in, with denim, with delicates, with permanent press, with the power of Happy Hare softener. Oh man, that's the last time I let AI write my intros. What's really on the horizon for ERCF fans is the new Happy Hare functionality, which includes automatic toolhead calibration. This is really groundbreaking stuff. No longer will you have to guess about toolhead measurements, ooze reduction values, or blade position. Happy Hare can now set those for you. The process is simple, but there are a couple of gotchas, so I'm here to guide you through the process and help you on your way. So warm up your hot end and untangle your filament because things are about to get calibrated.
Brrr.
All right, we're going to start with the cold pull. The cold pull cleans out the nozzle so we can get good measurements. It measures the filament by moving it in and out and checking when it stops using the encoder, I believe. So we're going to start this. We're going to go to the Happy Hare website. We're going to click on the wiki. And over here on the right, if you scroll down here to number 7, tuning, here's the blobbing and stringing. Now, this is a couple of different things. Mogi has implemented tool head measurements. So it measures your switches, your extruder gears, your nozzle distance, all automatically. It also brings in some Z-hop and ramping and some retract during tool changes to help with blobbing and stringing. Now, you can go through this and it talks about the key dimensions, has some really nice graphics here describing what each one of these measurements means. Another set with the tool head cutter so you know what they mean. But now we're going to come down here to the purpose of this video is calibrating the tool head. The first thing we need to do, of course, is get a clean nozzle. So step 1 is to perform a cold pull. I'm going to click on this link and that'll take us down here, which shows us we can do a manual pull, which I'm sure everybody out there has done. And we're going to do a cold pull with the macro. The macro assist works really well. It's pretty slick. All you do is you copy this and paste it into your command console. Now these parameters here, nylon, PLA, ABS, and PETG, are for the type of filament you're using to clean the nozzle. It's what you're going to load into the filament or into the tool head and pull out. This is not what was in there before. So one night when I was at the club, got a little buzzed, started walking home. Some guy came out of the shadows in the alley. He seemed kind of shady, and he says, "Hey, you want to buy some cleaning filament?" And I thought, what the heck? I might as well. I'm not sure, but I think he gave me just plain nylon filament. There is no magical properties to this. It kind of looks like nylon, kind of smells like nylon, kind of tastes like nylon. So I think it's nylon, and I'm just going to use that parameter. So I'm going to copy all this, and I'm going to paste it into the console. And before I hit the go button, I'm going to come over here to the tool head. I'm going to load my piece of nylon filament in there, and all you do is just push it in until it bottoms out. It doesn't matter as long as it gets down there to the top of that, whatever filament's left in there. So, as you can see, I've run this before. This is take 937, something like that. We'll hit the go button, and it's going to heat up the extruder. As it heats up the extruder, I want to talk to you about how to do the cold pull. I mean, what you're going to do. It's going to heat up the extruder, extrude some filament, pack the nozzle, and then it's going to tell you, pull the filament out. It doesn't tell you how. Through experience, like I said, take 937, you want to do a nice, slow, constant pull. If you yank on it, it's just going to break the filament away from the melted filament that's in there. So take it easy, nice, slow, kind of firm, not too gentle, but don't yank on it. Otherwise, you're going to be doing this again. And as you'll see, it takes a little bit of time. So now we've heated it up. It's extruded 25 millimeters of filament. And now you see it's stuffing the nozzle. That's just kind of packing the filament in there as it cools down to make sure that it is pushed into all the nooks and crannies, and it's got a good hold of any little bits and pieces of junk that might still be in there from the last filament. This is where it gets boring. All we're going to do is sit here and watch it cool down. When it gets to 200, it's going to stop stuffing the nozzle, and it's going to cool down to 50 degrees. Once it hits 50, it's going to warm up, and that's when you're going to want to be ready. So here it says, waiting for it to completely cool to 50 degrees. That's going to be a minute. I'm sure none of you guys wants to hear my lengthy lecture on Newton's laws of cooling. So I'll see you when it hits about 50 degrees. All right, we're almost to 50 degrees. So we're going to get over here and get ready. I'm going to try and reach around the camera here for you so I don't block the view. And you're going to see here, it's slowing down to 50 degrees. And once it hits it, it's going to start heating the extruder again, and it will tell me to get ready, and then it'll say pull now. And remember, we want to use a kind of a medium gentle pull. That's not a yank. Don't yank it out of there, otherwise you'll break it and have to do it all over again. So we're almost there. There we go, 50 degrees. It's going to start heating the nozzle back up. I don't know if you can see it here. It's heating up. We're going to get another toast notification along here that says to get ready right there, get ready to pull. And it says pull now, a nice, gentle, easy pull. There we go. Now, this is what it should look like. I don't know if you can see that, if it'll focus in or not, but it should look like the inside of a nozzle on there. It shouldn't be anything other than this. If it looks different than that, you probably pulled too hard, and that's going to look like it pulled the end off. And you'll know when, because if it doesn't look like that, you're going to have to do it over again. Sorry, I'm trying to keep it in frame. But yeah, make it look like that. Everything will be good. So we'll go on to the next step, which is the start of the tool head calibration. All right, now we're back to step 2. This is the tool head calibration. This is where we calibrate it as clean with a clean nozzle. This will figure out the distance from the nozzle to the tool head sensor, to the extruder gears, and to the extruder sensor. So basically all we're going to do is copy this, and we're going to paste that into our console. Now, one thing you want to do beforehand, and we'll see if you can see it over here on clicker screen, you want to make sure your gate's loaded. So I'm going to touch the caret icon, go to the manage, and then make sure your gate's selected, the correct gate. Here I'm on gate 6. I'm not sure if you can see that, but then just push this check gate. And it's going to partially load that gate, check it, sense it with the encoder, and then park it correctly. That way we know there's filament there and ready to go. Do that first, trust me. Now we're just going to hit the go button and let it do its thing. And you're going to see it run the filament down to the tool head, and you'll see it push the filament in. The extruder moves, so you know that the filament went through the extruder. It's going to push it down to the nozzle, test that. Now it's going to stall the extruder. It might even grind the filament a bit, but don't be worried because that's kind of supposed to happen. It pushes it until the encoder sees it stop and takes a measurement. And it goes back and forth a few times, pays attention to each one of the switches, and when it's done, it's going to pull it out, retract the filament. There you go. Now, if we look here, we have some measurements automatically done. It says it's at 93.9. It used to be 85. Well, that's pretty cool. So the next step after that is to come back here, and now we're going to do a dirty calibration. Now, what a dirty calibration means is it fills up the nozzle like it's normally been printing, and now we pull the filament out and leave all that in there. So this is going to leave that filament in there, cool it down, and then we're going to measure to the top of whatever filament's left in there, and that's going to measure the ooze reduction distance. Now, it depends on whether you've got tip forming or tip cutting. Now, I use the filametrics on this one, so I have to do this process here, and that takes a little bit of time, mostly because you got to cool your nozzle off. Anyway, what I'm going to do is I'm going to follow these directions. MMU load. Hit the go button. It's going to check for home because it needs to park the tool head in the park position. So that'll take a minute. Now you can see how nasty my print bed is. I should probably get out of the shop vac and take care of that. Now it's going to move over here to the park position, load the filament in. There we go. It says it's successfully loaded. Now I'm going to come over here. I am going to move the tool head back into the middle. There we go. Now, our next step is to manually extrude some filament. So we're going to heat the nozzle up. And I found it usually takes 50 or better. That's probably good. We'll hit the extrude and just watch it, see if it comes out. There we go. Very good. Now we're going to come back to here, and this command ejects the filament without running the tip cutting routine. Something you'll notice is it probably is going to give you an error, but that's okay. It's just because it doesn't have the slicer tip part position set, because you probably don't use it. Most people don't use slicer tip forming and cutting. There we go. It's unloaded the filament. Now's the boring part. We're going to cool off the extruder, and I'll be back in a bit when that happens.
Oh, disgusting.
Okay, it's down about 100 degrees, so it should be good enough to get a good solid stop to the filament without driving the filament in to melt the filament. So now we've got a dirty nozzle, we're going to do the tool head calibration and just enter this and hit the go button. And it's going to load the filament in, do about the same thing as it did before, only now our nozzle is full of filament. So what it'll do is compare the differences between the previous measurement and this measurement and figure out how much ooze reduction we need. And I think that's pretty cool. There we go. It's pushing it in there. Like I say, you might hear the extruder skip, or it might grind the filament just a bit. There we go. And measured our tool head sensor to nozzle, tool head extruder to nozzle, and tool head entry to extruder. And there we go. Now we've got an ooze reduction number. We've got a entry to extruder number. This is a repeat. It's done this before. They should be close. No big deal. If you've got a filament cutter in the tool head, like a Filametrix, we're going to run the MMU Calibrate Toolhead Cut 1. Now, with this, we're going to need to hold the blade in the cut position so it stops the filament and it can't go past. I'm going to reach my arm around there and try not to block off too much, but I'm going to copy this. I think I already did, but we're going to copy that, paste it, hit the go button, and then I'm going to reach around the camera, hold the blade in, and it does pretty much the same routine. All done. Now it's going to tell us where the blade position is, and it's going to set the variable retract length. Now the variable retract length is set at 5 millimeters. So this number here minus this number here, that is going to be the difference between how much filament's left and how much is cutting off. 5 millimeters is a decent amount. You probably can tune this a bit, increase this number a little bit, little by little, and that'll reduce the amount of filament that's being cut off, the size of the tip that gets cut off. Now, Happy Hare, when it cuts the filament, it shoves that cut off tip right back down into the melt pool so you don't get a clogged nozzle. And it adds to how much you're going to have to purge later on. So if you can shorten this down a bit, but still get a good tip, you'll have smaller purge blocks. It won't take as much time to purge out that filament. If you shorten this, you're going to extend your purge block, make it longer to get all that filament purged out. Anyway, that's it. That is how you calibrate the tool head. Now you've got all your measurements set automatically, and I think that is incredibly cool. Okay, the final step in calibrating your tool head is to enter all these into your printer config files. Now, the nature of Clipper is such that you can't directly edit the config files through automated means. So, yep, you're going to have to copy these guys down, and you're going to have to go put them into your config files. Now, here's a pro tip: write them down. You don't want to bounce back and forth and scroll up and down through your console, back and forth to the machine. Just write them down. I don't have an eidetic memory, so I can't do it through memory. And if I did have an eidetic memory, I wouldn't remember having it. So we're going to jump over here to the console. All these variables, write them down. Now we're going to go to the machine, and I'm going to start at the bottom. As you see, it takes some scrolling. Now these three are in the MMU parameters.cfg. So I'm going to come over here to machine, the MMU folder, the base. Now we've got MMU parameters.cfg. And that goes down a ways to here. There's all three of those. So the entry to extruder we measured at 8.8. The sensor to nozzle, we measured at 72.1. The extruder to nozzle, we measured at 93.9. Now, another pro tip, don't hit save and restart, because if you didn't write it down, you're going to lose everything on your console. So just hit the save button and then close out of the window. Now, the next ones, which are these two are also in the parameters, MMU parameters.cfg. So we're going to bounce back over there. MMU parameters.cfg, they're a little bit further down. Okay, here we go. Toolhead ooze reduction, we had at 26.5. An entry to extruder, we already set at 8.8, and it's repeated measurement. This next time we got 10, 8.8 to 10, it's not bad. I'm going to leave it. It's probably okay. So we're going to hit save, and we're going to close out of the window. And the last ones, whoops, wrong button. The last ones here, these two are in MMU macrovars.cfg. So I'm going to run over here again, find our macro vars right here, and scroll down a bit to here. There's our blade position, and it's at 52.8. And our variable retract length is at 47.8, which would be 5 less. And that's it. Now all you have to do is hit save and restart. Clipper's going to save those variables, and they'll be there when it wakes up again. Now you have a completely calibrated tool head. It should drastically reduce your blobbing and stringing. You can further fine tune it going into the retraction variables that are new to Happy Hare. But once again, this is going to help. This is really cool. I really think this is a big deal. So go back, show Mogi some love right here, please. And with that, you now have a fully calibrated tool head ready to lay down some smooth color changes. This functionality of Happy Hare is new and a great addition to already amazing software. If you want to know more about Happy Hare and how to set it up, try clicking on one of the video links shown here. This baby can fit so much multi-material.